Well, friends, we're talking about Math 105, Section 6.3, and we're going to deal with some practical transformations. And the problem that I'm going to start out with is let f of t be the height of a child in inches t years after birth. And the first thing that I want to do is I want to say, a lot of parents don't give the age of their child in years. They'll say, let g of m be the height of a child, m, we say in inches, m months after birth. And we're going to be asked to express g as a transformation of f. So what I'm going to say that we should probably do is I should write g with the variable, and note that m stands for months. This is going to be something to do with f, and I'm going to give myself a lot of dancing room here. But if I'm going to use an m inside one formula, I have to use the m inside the other. So now I put m in, m goes in there, but there's a problem. This m is in months. What goes inside of f? Well, t has to be in years. And so really, I have a unit conversion to do. We know that 1 year is equal to 12 months. I have m months, and I need to have years in here, and so I can put 12 months down, 1 year up. And so g of m is equal to f of 1/12 m, and we're done. Let's do another problem. Let's say I have a friend who says that the height of their child is fine. Let h of t be the height of a child in feet t years after birth. And so we can say that we're going to express h as a transformation of f. So we have h of t. We're going to have some function of f with t inside. Now, mind you, this t is in years, this t is in years, and so I don't have to do anything on the inside of my parent function, do I? But what I have to think about is that the height of this child in f is in inches, and I want the output here to be in feet. And so we can say that 12 inches is equal to 1 foot. I have inches, the inches have to go down, and the 1 foot has to go up. And so 1/12 f of t is our transformation. Let's now think about some additional shifts. Let's say p of m be the height of a child in inches, m months after birth. That is 3 inches taller than child f. Express p as a transformation of f. We have p of m is equal to some function of f. The same variable has to go inside, and once again we see that m is in months. What goes inside F is years, and so we're going to have a conversion factor that's months. Months has to go down. 12 months, 1 year, and we've taken care of the inside piece. The outside piece, the height of this child is the same, but it's 3 inches taller. The output here is inches, the there is inches, and we finished that problem. Our final child is, how about, let Q of V be the height of a child that is the same height as F, but this child is half a year older. So what's the dream here? We're going to start out, express Q as a transform of F. And, you know, what I might want to do is, sure, we're going to have Q of V. V is in years, yeah? And we're going to have F. And if I have a variable here, the exact same variable has to go inside. But what I'm going to do here is I'm going to make a little table for us that Q of 0.5 is equal to F of 0. Because this child is half a year older than that one, yeah? And they're the exact same height. Q of 1 will equal F of 0.5. And I think once I make a couple of these, I can begin to see what the relationship is between the value here and the value here. If I put a half in for V, what do I have to do to get a 0 out? If I put a 1 in, what do I have to have in here to get a half? And so we're going to have negative 0.5. Another way of writing that would be V minus 0.5. So I can't recommend enough, if you're stuck on whether or not you're going to have a plus or a minus, think about a situation and plug some values in. What I think you should probably avoid at all costs is thinking about this in terms of a right shift, left shift problem, because we're really just working on mathematical literacy here. I don't have graphs to be able to think about what's being shifted on top of another.